Hi, welcome to the next session, session number 4 of number system class 9. In this session, we are going to discuss exercise 1.2 of NCERT. The exercise is having very less number of questions, only 3-4 questions that have. So let us go with the very first question, and the first question says, state whether the following statements are true or false. We had to state the true and false about the concept of them, whether this concept is true or false. So the first thing this says is every irrational number is a real number. What they are saying? Irrational number is a real number. We know that if this is a set of real numbers, then this is a set of rational and this is a set of irrational numbers. That means all the numbers which are irrational, they by default fall in the category of real numbers. So every irrational number is a real number, and this statement according to this holds true. See, it is not only true or false, it is the way in which we had to learn. We don't have to write only true, okay, it is false, it is true, then again true, then false. No. We had to learn why it is true. The another question says, the question number 1 part 2 says, every point on the number line is of the form a square root of m. Say this is a number line, and on this number line there is a point 0, 1, 2, 3, or say I can take negative also, minus 1, minus 2. And it says every point. Let's say I will take a point here, okay, and it says it is a square root of m, and m belongs to natural number. This says every number on the number line. Now with this number line, this statement, what they want to say is revealing here within the number line. Say m, say if I will take, let's say m, I will take 4, and square root of m is nothing, it is square root of 4, which is 2. So somebody says, yeah, we can represent, but is only 2 only the number, or 1 is only the number, or 3 is only the number? There are other numbers also. Let's say if I will say square root of 0 is 0, this is this. I will say another number, but is 0 belongs to natural number? No, this is not belonging to natural number. So every number on the number line can't be represented with the help of this square root of m. Or I can also say all the negative numbers are unique in themselves and can't be square root of natural numbers. They can't be the square root of natural numbers. Never be. They can't be the square root of the natural numbers. Clear? So this statement is every number on the number line cannot be stated in this. So it is a false statement. They say it can be represented, and we have proved it can't be represented. Another one, every real number is an irrational number. Every real number is an irrational number. Again the same, I have explained this in the first part of this. If this is a superset and here I have irrationals, I have rationals, and as a whole they are real. So every real number is a collection of irrational and rational. So all the real numbers are not only irrational. So this is again a false statement. This is a false statement. Let's come to the question number 2 of this one, and the question number 2 says, are the square root of all positive integers irrational? This says, question number 2, square root of all positive integers, square root of all positive integers irrational. Yeah, very nice exam. It is a very confusing one. Say, normally what the mistake a student is going to do, we always think the example which will satisfy this. Let's say I will take an example root 2. It is irrational. I take example square root of 12. It is irrational. Square root of 7. Irrational. But all are positive, all are irrational. I will say, a student will say, yeah, it is true. But if I have even a single example which will just obsolete this statement, contradict the statement, then what is the statement is? For example, if I will take square root of 16, what is this? It is 4, or I will say plus minus mod of 4, which we have explained, it is 4, positive. So, is it irrational? No, it is a rational number. All the whatever, let's say I give n number of examples which is satisfying this. I give only a single example which is contradicting this statement, and with the contradiction of this statement, this statement becomes false. This is a false. False. Now after this it has if not. Yeah, they are saying if not. Give an example of the square root of a number that is a rational number. Yeah, we have given. This is an example. So we have completed this question. Again, comes to the question number 3. The last question we have for us in this exercise, which is question number 3. Let's go question number 3. They say represent square root of 5 on number line. Solution is very easy. We will try to find out this one. We just use n minus 1 whole square plus 1 whole square is equal to square root of n. Like this. We will follow this one. Now what is this n? We have discussed this one thing. This is 1, this is n minus 1, and this is square root of n. So here I had to represent this one. So I will put n equals to 5. So what will I have? I will have root 5, 1, and it will become 5 minus 1, and it becomes a square root of 4, and it becomes 2. So very easy. All my work becomes so easy that whatever this number line is, this is 0, this is 1, this is 2. So I will take, this is the square root of 4, which is 2. So I will take this as 2 and mark a line here equals to 1. Unit, I will mark a line and then I will join these two lines, which becomes a square root of 5 according to this one. And then what I will do, I will just take my pointer of the compass here and just mark like this. I will mark like this. Okay, and this represents, again this will represent root 5. So this is how I can represent square root of 5 on the number line with the help of this. Just please remember, this is very important. Okay, So like this we will be able to do all the questions of this exercise. So I'm just concluding this session here, and hope that you have understood whatever I have told to you, and let's meet in the next session and to discuss more about irrational and rational numbers. Okay, have a nice time. Thank you.